Hi, today we're going to do vector proof using the 2D shapes. Now, before we start, you need to know some basic rules about how to draw vectors. So let's have a look. So as you can see here, there's a line there goes from A to B. A is the tail of the vector, B is the head. And we write it as vector AB, like on the top here. And we can also write this as negative vector BA. Now, this negative is going opposite direction. Vector BA is going this way, but if it's opposite, it'll go this way, which is the same as a vector AB. You need to really understand these different ways of expressing vectors. Now, position vectors are the one that actually starts from the origin on the number plane. So here, origin to A is called vector OA. And if it goes origin to B, it's a vector OB. Now, addition of vectors, if you look at vector OA and vector AB, they're actually going the same direction. But vector OB, it's not, because vector OB is a total vector of vector OA and vector AB. Vector OB has the same starting point as a vector OA. Just remember that. So the equation of this sum, the total vectors, is vector OA plus vector AB equals vector OB. And we can also rewrite this, so making vector AB the subject. Let's have a look at the question 1. Use vectors to prove that the quadrilateral ABCD is a parallelogram if the diagonals bisect each other. So I'm just going to use, there are about 5 or 6 properties, but I'm just going to use one for this proof. So I'm going to use that a parallelogram has equal opposite sides. So that means AB is equal to CD and BC equals AD. So put that into vector term, it'll look like this. So as you can see, the outside edges of the parallelogram, the vector goes on all the same current to AB, BC, CD, DA. So if I can just write it as a vector term for this one with BC, CD, DA, AB. Now also diagonals has the directions too. Diagonal AC and diagonal BD. But because there's a midpoint that it's going to meet in the middle, O, I could say that vector AO and vector OC are the same, and also vector BO and OD are the same. And that is given because it was given information from the question. So I'm going to use that given information to prove that ABCD is a parallelogram. I'm going to use that property. So I'm going to use this as my proof. So if I can prove that vector BC is same as, equal to, opposite to vector DA, and then vector AB is equal to the opposite to vector CD, that means it is parallelogram. So let's have a look at that. First, I'm going to prove that vector AB equal to opposite to vector CD. So I'm going to prove this using these 2 blue triangles here. I know it looks like a parallelogram, but at the moment, we don't know that's a parallelogram or not. We can't just assume that that is parallelogram until we prove it. Vector AB, so that's this one, vector AB, and plus vector BO equals vector AO. Now, vector AO is the total vector. So I'm just checking the vector AB. So I'm going to change this in terms of vector AB. Okay, we can replace this vector AO and vector BO in terms of vector OC and vector OD. Okay, so I'm going to replace that. Vector AO, I can replace with the vector OC. Vector BO, I can replace with OD. Let's have a look at it carefully. Vector OC is here right now. And then vector OD is going this way, but it's got a negative. So it's going to opposite direction right now. Okay, that looks all right. Now that we're looking at this triangle right now, that's same as vector DC, which is opposite vector CD, which is the same as this. So therefore, we can say vector AB equals opposite to vector CD. Okay, so we've done first one. So remember, vector AB is same as opposite to vector BC. Now I'm going to prove vector BC is opposite to vector DA. If vector BC is this one right there, vector BC equals vector BO, which is this one, plus vector OC. Just looking at this one, OC. Okay, now I'm going to use the given information and replace it. Vector BO can be replaced with OD, and vector OC can be replaced with a vector AO. Vector OD is going here. OD here, and then plus vector AO is here. AO. So they're all going to the same current there. So it has to be going that way. So that equals to vector AD. Now, vector AD is also the same as negative or opposite vector DA, which is the same as that. So therefore, vector BC equals opposite vector DA. So we just proved that. So therefore, your final answer, you need to write quadrilateral ABCD is a parallelogram. Let's have a look at question 2. A triangle has vector CA equals vector U, vector CB equal to vector V, and M is the midpoint of line AB. Illustrate this information with a diagram, then show part 1, vector BA equals vector U minus vector V. So I just illustrate that. Vector BA equals, okay, so it's going BA this way. Vector BA plus vector CB, which is this one, CB equals vector CA. Now we know that vector CB is V, vector V, and CA is U. So if I change that in terms of making the vector BA the subject, it would be vector U minus vector V as required. Okay, just be careful of the current where it actually flows. And the total vector is not obviously going with the current. Okay, so it's the same question, but it's part 2. So the proof that we have to have is vector MB is negative half vector U take away vector V. I'm going to go vector BA equals, so BA, that's a vector BA, because at the moment current goes from A to B. I can say we are opposite direction, but it's a double of vector MB. See, because M is a midpoint of AB, AM and MB are the same, and it's a half of AB. And with the vector term for vector BA is double, but it's a negative direction, double of vector MB. From first proof, we know that BA equals vector U take away vector V minus 2 vector MB from here equals vector U minus vector V. In terms of MB, I just have to divide it by minus half on each side. It'll be same as vector U minus vector V as required. So from the part 1, we know that vector BA is vector U minus vector V, and from the diagram, we know that vector BA is negative opposite direction of MB, but it's doubled. Okay, the last part, looking at the diagram here, I just sketch the vector CM. So we have to prove vector CM equals half of vector U plus vector V this time. CM equals, that going to the same current. So that's a U, vector U, plus vector AM, isn't it? Now, vector AM is opposite direction of half of vector U minus vector V, because vector AM equals vector MB. Same, isn't it? Which is half vector U take away V from the part 2. And if I expand it, it'll be like that. It'll be half vector U plus half vector V. And I'll take the half out. I'll get U plus vector V as required. So just be careful. I think if you know the current, following the current for the adding the vectors, and then when the current is not following, you automatically have to think that's the total current, total vector. Also, if you want to change vector direction, don't forget to put opposite, the minus in front. Hope that will help. It was a little bit confusing if you don't know the characteristics of vectors. So make sure you practice the basics of vector before you tackle the hard or tricky questions in proof, especially with the 2D shapes. You also need to know the properties of 2D shapes. Okay, have fun and see ya. Bye.